Hello and welcome to Web Learning where knowledge is shared. In this video, I'll show you how to update the CubeMX and what are the features of the new CubeMX 5. If you still don't have the CubeMX, the best way to do this, either use the link in the description below or just Google download STM32CubeMX and that's the first link that you will get. This will bring you to this page all the way to the bottom. Get software, accept, register or login and download. If you already have the CubeMX, the best way to update the CubeMX is Help, check for update, click Refresh, then Update to the latest CubeMX and Install now. So after the software has been updated, I need to click Close, close the CubeMX and restart it as administrator. So here get a new window and on usage statistics. So you can click yes, remind me later, or no thanks. This is the new STM32CubeMX. As you can see, it has a different GUI, but most of it will be the same as the previous CubeMX. I will not go on all the features and everything. If you want to learn about the CubeMX, the best way is to go back and view the few training videos that I made on the STM32CubeMX, the updates, and then come back here as I'm showing only the updated GUI. In the first side of the window, this is existing projects. So if you have any existing projects, you will see them here. Here you have open existing projects and you can click on this blue folder. If you want, you can access the MCU selector or directly access the board selector. This is to find different microcontrollers. This is to find different boards. If you want to check for updates, at the beginning was help and check for updates. Now there is a button here. If you want to install embedded software packages, you can do it from here. Before I continue, I'll click check for updates. As you can see, I have the L0 update and the F4 updates. In the old version, I didn't see those because those packages are only supported by the new version. I will quickly update the L0. And for the F4, I will do it later. As you can see, updating packages, there is no need to restart the software. Click close, install remove software packages. Here you can either manually update new packages like the F0 or the F1 or any other microcontroller. And here there are software packages. This is for the Blue Energy Bluetooth stack. This is for the BLE1, also the Bluetooth stack. This is for the MEMS. This is the drivers and application for the MEMS components from ST. That I'll do a video in a later stage, or you can already search for it in the list of videos that I have. Under File, it's pretty much stayed the same. New project, load project. Under Window, these are the different outputs of the microcontrollers that you can find. And Help, again, it's the same for check for updates, manage embedded software packages, and update their settings as before. In order to see how it looks, let's do a quick project on the L0 Nucleo board that I use. So access the board selector, or let's start with access the MCU selector. Here we can see it's pretty much the same as before. You can either look for a microcontroller by clicking some part number of the micro, and then you can see the rest. Here you can reset all filters. You can search by core, you can search by series, and you can search by other parameters. In this Cube version, we have few new microcontrollers that are out. There is the STM32WB, that's the Bluetooth microcontroller. There is the L5 that soon will be coming out, that's a secure microcontroller. There is the G0, also a new microcontroller that will come out from ST very soon, and the rest are the same. Here at the bottom, again, you can see all the peripherals. If you hover on any of the peripheral, you can see exactly what the abbreviation means, and you can click on details and documentation to get better understanding of what the peripheral is doing. Some peripherals you need to tick them because you either have them or you don't have them. Some peripherals you can decide how many you want of them. For example, with the CAN bus, you can have either a microcontroller with one CAN bus or with 3. That narrows down the whole list of available parts. Going back all the way to the top, I can go to the board selector. I'm using the L053 Nucleo board. Here it is. Double click. I want to initialize all peripherals to the default mode. I can click no or yes. Okay, so what are the differences? First of all, I can go back to home. I can click and search a different board, or I can go to the project that I'm doing right now. So this is untitled Pinout configuration because I haven't saved it yet. Then you have the Pinout. The clock configuration looks the same. The project manager that we had before in a different window, it's right here, tools. This is also called power consumption calculator, but now it's different. Here you have a small link to see the datasheet, and the power consumption calculator is pretty much the same by clicking adding steps after choosing the right voltage, and everything else will work. To generate the code, you need to click here, generate code. Again, the project name cannot be empty, so it won't run. But let's go through the whole process and see how it works. New GUI looks a little bit different in the way that the windows are structured. First, we can still zoom in and out using the mouse button wheel. We can also zoom in and out using the buttons here. We can best fit. We can rotate the part. We can do flip horizontal or flip vertical. If you want to search for any pin, it's also done here. For example, PA12. And it's the same way as before. If we want to see the things that were set in the system, we can click on System View. And then we can see that now there is the DMA, GPIO that is not set yet, the NVIC and the RCC. The first thing we want to do is add the debug functions. The way we do this is clicking the system core, clicking on sys, a new section will open up for us. These are all the mode options that we can have under sys, and what configuration for sys. If this section doesn't open up, there are those two small arrows that you can click on them, either have it completely opened, half open, or closed completely. You can click on the bar to move it, and to close it back on, click on the top arrow, those two small arrows. As I said, we want to debug the device. We want to have those pins enabled. So click debug, and the CubeMX will set the pins correctly. All the other features will also open new information in this section. For example, for the GPIO, I can see all the GPIOs that were set. I can click on any one of the GPIOs and I can see the GPIO configuration, either output level, GPIO mode, the pull up, and the rest of the information. In the previous code, you had to go to a different window and search for each option depending on what you chose, and you had many screens and many different windows. With the CubeMX 5, everything is right here. It all depends where you click. This is the same for NVIC or RCC. Again, I can choose on the high-speed clock if I want to bypass or ceramic, and I can see all the configuration of the high-speed clock. There are other ways to find the peripherals that you're looking for. In this mode, we are under categories, so all the peripherals are set under categories. I can also click on A to Z, and I have all the peripheral names sorted by A to Z, or I can be in categories and just search what I'm looking for. For example, duck, and search will find the peripherals I'm looking for. If I want to choose ADC, I can click on ADC, then I can turn on one of the ADCs. I can see the complete configuration. Again, if it's too small, you can click on this arrow to open it completely, and then you can see all the configuration of the ADC. You can also lift this up, and then you have the parameter settings, user constant, NVIC settings, DMA settings, and GPIO settings. Turning the analog off, it will close all the configuration. The same thing with the timers, real-time clock. You can always see all the parameters, the peripheral that you're dealing with. The peripherals are set to system core. You have the DMA, GPIOs, independent watchdog, NVIC, RCC, where all the clocks are. System, sys, where you have the debug wires, VRF int, the ADC, the power voltage detector, touch sensing, and window watchdog. Under analog, you have the ADC, comparators, DAC. Under timers, all the timers. Connectivity, I2C, low power UART, SPI, UART, USB. You might not see all the peripherals here, and that's just because the CubeMX is loading only the peripherals that are existing for this specific microcontroller. If you're using a bigger microcontroller or a smaller microcontroller, this list will change accordingly. Under multimedia, you have the I2S on LCD, security, random number generator. Under computing, the CRC, and here you can see the middleware. Some of the middleware is operational because it's not peripheral independent. Some peripherals are grayed out, and that's just because it's peripheral independent. For example, the USB device. If I go back and turn the USB on, you can see that the middleware is on, and now I can switch it to audio device class and any other class that I want to. For this example, I just need the LED on and off. After setting the system, I can go to system view. Here again, I didn't turn anything on, but if I go back and turn on the ADC, you can see that I can have all the system things line up in the same window, and what was turned on and what is activated only. The yellow triangle, you hover it, it will also give you why you're getting a triangle and not a green circle. Signals are not used in any IP mode, you can still generate code. In this case, going back to the pinout view, as you can see, some of the pins are already set but have no peripherals set to them. Here we have another button called additional software. This is part of the embedded software packages that I showed you before. So if I go back to Untitled Additional Software, here we have the BlueMS Bluetooth packages, the BLE and the MEMS1. In this tab, I can either have pinout mode, I can undo a pinout, keep current signals placement. Again, this is very important. After having your PCB, you don't want to have any of the pins changing if you're rerouting different GPIOs or peripherals. Disable all modes, clear pinout, clear single mapped signals, pin signals options. Again, these are all the pins, all the user labels that we gave them. And I can also add a user label, right-clicking on a pin and then entering a user label. Here we have list pinout compatible MCUs. It's asking me to save a project. What the system just did now, it went and looked at pin compatibility. So it looked at all the series, all the packages that the iCUBE P64, because they are the same as this device that we chose. We can do the search option as ignore pinning status, ignore power pins, and ignore system pins. If we ignore all those three important things, sometimes they are okay, sometimes they're not. It depends on what stage of the project you have. For example, if you already have a PCB, then you cannot ignore power pins or ignore system pins. Here, you get the full list of parts that are compatible. The blue, you have full compatibility, so it doesn't matter which one of these you'll choose. They'll be just the same from the footprint and from the software side of things. The green are hardware compatible, same device, same functions, but you need to do some minor tweaking in the software. And these devices, you'll need to change the hardware as the pinouts are not the same. If we untick the ignore power pins and ignore system pins and click back on search, we can get only the parts that are fully compatible. After we get the list, we can click on one of the devices and click import, and the CubeMX will open a new design with the new part that we decided and will import all the settings that we had already. Here at the bottom, we can see again all the compatible devices. We can close this view by clicking Window and clicking Outputs. So after finishing all the GPIOs and everything, now we can click Clock Configuration. Again, the clock configuration is just as before. As I said before, I suggest you go back to see the CubeMX full trainings if you haven't done this yet. Project Manager, I can see the naming of the project that I already gave. The code generator, I can decide on what type of tool I want to generate the code to. Is there QStudio, Kyle, IAR, AC6 or STM System Workbench, and Makefile or other tool chains, and the MCU firmware package that is used to generate the code. After that, we can do code generator. This is to decide on which firmware library packages and how you want to use them, and the HAL settings, set all three pins as analog input. Advanced settings, you can see what type of code is generated for the project, either HAL or LL. In this case, I'm not going to do any power consumption calculator, So the only thing left for me now is click generate code. Open project. I forgot to change this to True Studio. So back again to project manager, project, True Studio. I don't want to generate under root, generate code. Open project. Open the project, application, user, main. I'm going all the way down to the while one, HAL, GPIO, toggle, compile, click OK, click resume, and everything is running fine. To terminate, click on the red button, or you can pause it, suspend it, and that's it. I hope you found this tutorial informative. Don't forget to subscribe and click the notification button. You can follow me on Twitter, Instagram, and Facebook. Thank you for watching.